Hey there, HackerFrogs! This is the fourth Intro to Web Exploitation workshop. In the previous workshop, we learned about the following web exploitation concepts. Structured query language is a programming language used for managing data held in relational databases. Simply put, SQL allows users to access and manage data contained in relational databases, which are common components in most web applications. In the previous workshop, we used SQL queries to retrieve relevant data to gather clues and solve the SQL murder mystery game. Moving on to this workshop, we'll be learning SQL exploitation through the TryHackMe platform. TryHackMe is a popular cybersecurity education platform with education modules that span a great number of cybersecurity disciplines. In this workshop, we'll be making use of one of TryHackMe's interactive rooms to learn more about SQL exploitation. But if we want to use the TryHackMe platform, we must first have a valid user account for the website. If needed, sign up for an account at the following URL. SQL Injection is a web app vulnerability where SQL commands are passed to the web app database through insecure user input. SQL injection vulnerabilities can lead to sensitive data exposure, admin account takeover, web server takeover, and more. To learn more about SQL injection, we'll be working through a TryHackMe room. In a web browser, log into the TryHackMe site, then navigate to the following URL. The first thing we need to do upon loading up the web page is to click on the green Join Room button at the top of the web page. In the Task 1 section, there is an overview of what will be covered in this room. The only question in this section is, what does SQL stand for? In the question field, type in Structured Query Language, then hit the return key. In the Task 2 section, there is an explanation of the structure of databases, where they are broken down into individual databases, which contain one or more tables, which in turn contain a number of columns and rows. A column is a label that specifies what type of data should fall under it, and a row is an entry into that column that contains data that corresponds to the column's name. There are two questions in this section. The first question is, what is the acronym for the software that controls a database? Type in DBMS, then hit the return key. The second question is, what is the name of the grid-like structure which holds the data? The answer is tables. In the Task 3 section, there is a lot of useful information regarding the syntax of the SQL language. One important detail to note is this SQL statement here, which illustrates a typical SQL statement which might be used in web app login functions. In a web app, if this statement were to be supplied by the user, it would log the user in if the statement returned true. Another important section to take note of is this section on union select statements. Union select statements allow rows to be returned from multiple tables at once, provided that the number of columns returned from both queries are the same, and the type of data returned from each set of columns is also the same. In the question portion of this section, the first question asks what SQL statement is used to retrieve data. In the answer field, type select and hit the return key. The second question is, what SQL clause can be used to retrieve data from multiple tables? The answer is union. The third question is, what SQL statement is used to add data? The answer is insert. Under the Task 4 header, we learn about SQL Injection and how it can be used to retrieve entries from the database. In this first example, there is a website that retrieves blog articles using a SQL database select query. The SQL statement used here has a clause that only allows articles to be retrieved if they have the private flag set to false. But if we were to inject malicious SQL code into the blog article retrieval query, we can access articles that would normally be forbidden due to the private flag restriction. We do so by using the SQL comment symbols to omit the portion of the statement that contain the restrictions. In the question section, there is only one question. What character signifies the end of a SQL query? In the answer field, type a semicolon, then hit the return key. Under the Task 5 header, there are 3 types of SQL injection techniques described. Inbound SQL injection is a broad category of SQL injection attacks where the output of the SQL query is returned directly to the web app interface. Error-based SQL injection is a type of injection attack where the presence or absence of data is determined through error messages returned to the web app. And union-based SQL injection is a type of SQL attack where database entries can be returned if enough details about the original SQL query can be determined. We'll now do an interactive exercise demonstrating union-based SQL injection with the vulnerable web app. Scroll back up to the top of the Task 5 section and click on the green Start Machine button. The web browser window will split into 2 panes, with the left-hand pane displaying the TryHackMe website and the right-hand pane displaying the vulnerable web app. The web app will take between 1 and 2 minutes to load. Within the web app, we see a simulated web browser and URL address field. It is through this address field that we will conduct our SQL injection attacks. We also see the contents of the web page here, and the construction of the SQL query provided below. In order to identify SQL injection vulnerability, we must first determine whether or not the web app is using a SQL query to retrieve data. We do so by adding user input that will result in an error message that reveals the use of SQL software, such as including a single quote or double quote at the end of the input string. The error message here explicitly states that a SQL database is being used to retrieve data, specifically MySQL. Next, we'll use a union select query to determine how many columns are being returned by the original SQL query. The SQL error indicates there are a different number of columns between the original and our union select, which is currently at 1 column. So we add another column and try again. This time we union selected 2 columns, but it still wasn't enough. So we try again with another column. And this time, relevant data is returned. So we know that union select is valid when returning 3 columns. But we don't see the numbers we included in the union select because the web page returns the article data first. So we need to adjust our SQL injection string so that no data is returned for the article part of the query, which we can do by supplying an ID value that doesn't exist in the article table, such as 0. From the placement of the union select numbers, we see that column 1 is the article number, column 2 is the title of the article, and column 3 is the body text of the article. The next step in this SQL injection attack is to determine the name of the database used by the app, which we can do by substituting the column 3 in our SQL injection string with the database function, which returns the name of the database used. The name returned to us is SQLi_1. We can use this information for further enumeration of the database contents. The following injection string, which includes the name of the database, will return the names of the tables contained in the database, but it will also return the information in a single row due to the use of the group concat method. Use of this technique is necessary, since this web app has demonstrated that it will not return any data beyond the first row. So since we know that there is a potential target in the database, the staff users table, we can enumerate the columns in that table with the following injection string. We once again use the group concat method, but this time we're returning the column names from the staff users table. We see that this table contains the columns ID, username, and password, which we can further enumerate with the next injection string. We continue to use the group concat method, but here we're specifying a format to return the data in. That is, a colon between the username and password, and a line break acting as a separator between the rows that are returned. This makes the data returned to us much more legible. The Martin user account password is the objective for this level. So we copy the password and submit it to the answer field in the web app. On the next level of the web app, we see that there is a flag here. So we copy the flag, go back to the TryHackMe webpage, paste the flag, and click on the Submit button. Under the Task 6 header, we learn about our next SQL injection topic, blind SQLi. Blind SQL injection is a type of SQL injection where the results of the SQL injection are not explicitly returned via the web app interface. A well-known method of blind SQL injection is the authentication bypass, where authenticated access to a web app is achieved via SQL injection. This vulnerability exists in web apps where SQL queries are implemented in an insecure manner. In the web app, we see that the SQL query used here looks for matching values in the username and password columns, and if a matching pair is provided, the user is logged in. But a matching username and password isn't the only way the web app allows an authenticated login. It's merely the expected way. In fact, the system is only looking for a condition that returns the SQL query true in a boolean sense. And we can inject a SQL string that will return the SQL query true even if we don't know any valid username or password, by providing the following string. So what does this string do in a SQL context? The single quote closes out the original query, username equals ... If this portion is not included, the SQL database will return an error. The next part, OR, is what enables the bypass, because it allows us to create our own true statement. Even if there is no matching username, because the OR conditional is used, the overall query can return true if we supply the correct statement, which in this case is 1 equals 1. This is followed by the semicolon, which terminates the statement. Then double dashes and space, which comments out the rest of the original query. When we click on the Login button, the web app informs us that we've bypassed the login and we can move on to the next level. So we click on the Level 3 button, and we're presented with a flag for completing Level 2. So we copy this flag and submit it to the question field in Task 6. Under the Task 7 header, we're introduced to another type of blind SQL attack, boolean-based injection. Boolean-based SQL injection is a SQL injection attack where certain statements are confirmed true or false by the SQL system, and in doing so, allows us to enumerate the database's structure and contents. Boolean SQL injection is heavily dependent on the like operator and the percentage wildcard character. In the web app, we see that there's a web page which returns to us whether a certain username is present in the system. First, we will find a string that will return a false result. Then we'll use a union select query to determine how many columns the original query returned. When the number of columns is correct, the web app will return the true result to us. After determining the correct number of columns for our union select, we can begin our enumeration. This is the string we'll use to enumerate the name of the database. The like operator and the percentage wildcard character are used to provide partial matches. We supply the SQL system different letters and numbers for the first character until we see a true result. Then we guess a second character until we see a true result. This is a very time-intensive, iterative process, and there are automated tools that make this process easier. But it's good for us to understand the process of conducting this type of SQL injection for education purposes. After enumerating the complete name of the database, we discover it is SQL_3. We can confirm that in the SQL injection string that returns true. Then we can repeat the process for table names. And then column names. Using this method, we can eventually determine that the user's table has 3 columns: ID, username, and password. Next, we enumerate for usernames in the user's table with the following injection string, which eventually leads us to a valid username, admin. This leads us to the final step, determining the admin password. After iterating through all of the characters, we determine that the password is 3845. We can then use this username-password pair to log into the web app. This allows us to progress to the next level, which reveals the flag for task 7. We copy the flag and then paste it into the question field in Task 7. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. Under the Task 8 header, we learn about time-based SQL injection, which is similar to boolean-based injection in most ways, except that there is no visual feedback to indicate whether or not an injection string has returned true or false. Rather, time-based SQL injection makes use of the SQL sleep method to delay the return of successful injection strings. For example, if we inject a true statement into a SQL query and use the sleep5 method, the response time of the query will be delayed by roughly 5 seconds. But if the SQL query is false, then the response time will be immediate. Each time there is no delay in response time to the string. We can assume that our injection string returned false. We're given a potential injection string for determining the database name. But to save time, let's guess that the pattern for the naming of these databases has not changed, and try to confirm that this SQL database will be named SQLi_4. Then let's assume we're looking for a users table and use the same injection string from the previous task. But remember to adjust the string because we're only including 2 columns, and the name of the database is now SQLi_4. We try the table name users. And the response time seems to support that. Now let's assume that there are username and password columns in the users table, and that we're looking for the admin user's password. We can then use the injection string from the previous task where we're trying to determine the password. Iteratively, we learn that the password is 4, 9, 6, 1. We can use this set of credentials to log in. Which completes the exercise. We're rewarded with this flag, which we can copy and submit as the answer for the Task 8 question. Under the Task 9 header, we learn about the least common type of SQL injection, out-of-band SQL injection. Out-of-band SQL injection is uncommon because it requires the SQL software to be able to send SQL data out of band, that is, outside of the web app's domain, as opposed to in-band or blind SQL injection, where results of database queries can be seen in the web app. Out-of-band attacks require two different communication channels, one to launch the attack and the other to gather the results. In a typical out-of-band attack, the attacker injects SQL queries to the SQL database via the web app. The database then sends the output of the SQL injection via HTTP/DNS traffic to the attacker's web server, which receives and logs the results, and can be retrieved by the attacker at their leisure. In the question portion of the section, we're asked, name a protocol beginning with D that can be used to exfiltrate data from a database. Type in DNS, then click the Submit button. Under the Task 10 header, we've come to the remediation section of the module. This section goes over some of the preventative measures developers can take to better secure their web applications against SQL injection attacks. There are 3 measures of remediation recommended here. The first measure listed is prepared statements with parameterized queries. Prepared statements are SQL code written in such a way that the user input is compartmentalized away from the SQL query. In addition, the queries are parameterized, which further serves to isolate user input from SQL statements. The second suggested remediation method is input validation, which filters or modifies user input that includes special characters. Special characters in user input are what enables SQL injection attacks, and input validation helps in securing web apps. The final suggested remediation method is escaping user input, which also targets special characters in user input. But escaped user input modifies special characters in such a way that SQL software will not interpret these characters as code. In the question portion of the section, we're asked to name a method of protecting yourself from a SQL injection exploit. Type in prepared statements and click on the Submit button. Congratulations, we've finished this room. Let's review the SQL concepts we learned in this workshop. SQL injection vulnerabilities can lead to sensitive data exposure, admin account takeover, web server takeover, and more. In-band SQL injection is SQL injection where the results of the injected query can be seen in the output of the web app. It is considered the easiest type of SQL injection to exploit. Error-based SQL injection is a type of in-band SQL injection where error messages from the database software are returned to the web app interface. Union-based SQL injection uses a SQL union operator with the select statement in order to output additional database information from the web app. Some useful SQL commands include the following. This command returns the name of the database used by the web app. This command returns all data in a single column with the group concat function and gets the names of all the tables contained in the specified database. This command uses group concat to return all results in a single column and returns all of the column names from a specified table. This command uses group concat to return all results in a single column, returns all rows from the named columns from the specified table, separating the results from each row with an HTML line break. Blind SQL injection is SQL injection where the error messages resulting from improper SQL queries have been disabled, but the requests are going through nonetheless. Authorization bypass is a type of blind SQL injection where insecurely written code allows the login of a user to a web app without the use of a proper username and/or password. The most basic auth bypass SQL command is illustrated by the SQL command shown above. Note that there is a space present in the command after the double dashes. Boolean-based SQL injection is a type of blind SQL injection where the only output that is returned after a SQL statement is whether the query returned true or false. The key to using Boolean-based SQL injection is the use of wildcard search queries to incrementally determine valid database contents. Time-based SQL injection is a type of blind SQL injection where we give the database software an instruction to return a delayed response, and if so, we know that the attack was successful. The SQL feature that we use in time-based SQL injection is a sleep function, where the number of seconds the response is delayed by is indicated in the parentheses. Out-of-band SQL injection is a type of SQL injection where the output of any SQL queries can be passed to services outside of the web apps network. One example would be where SQL injection is able to trigger a DNS query lookup to an attacker-controlled server. SQL query output would then be included in the logs for the out-of-band service used. This is the end of the web exploitation workshops for now, but join us next time when we'll be starting our next subject, digital forensics. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!